So the scope determines where a variable lives and how long it lives. And this is important to always know exactly what scope should something live, because otherwise you're wasting space, or otherwise you could interrupt something else, right? And this is important. So actually, let's put. Actually, what? So terms and whatever else, scope, the life of something. Okay, so variables and whatever else. And this is really important. It's determined by, let's say, these. These are an easy way to reference them. So whatever you create inside here will stay within the gates of the scope. Okay. So we get a user value. We ask for the value. He has to enter something between 0 to 5. If he enters anything else, we want to keep asking the question. So we want to make sure there's a limitation between 0 to 5. So how would I do that? What should I write here, guys?
So can you please repeat the questions?
By the way, if I go too fast or if you can't hear my voice correctly, let me know. Um,
Yeah.
so we're asking the user, I want him to enter a number between 0 to 5. If I don't get that number, I want to repeat this question.
So, condition in while
Okay? Condition
if
well.
value if value is smaller than 0 or a user value greater than 5.
So, and we need a semicolon for a do while.
Yeah.
Okay, so do this while this is true. Notice that he did the inverse, right? So while it's wrong, I want to keep redoing this. And we're using a do while, so it will do this at least once before it asks any questions, right? So let's, as always, we're gonna run something just to make sure that our code reaches here. We're gonna put reached, right? So run our code. Let's see where it goes. Notice it's a while true, right? And a while true, we got an infinite. So here, if I put 8, it says wrong, right? First thing, maybe I want to put a colon and a space to make this look a bit cleaner. If I put 10, okay, good, your stuff is working. If I put -1, still working. -2, it's still working. Let's not put letters yet. We'll deal with that soon. If I put 0, I reached. If I put 1, 2, 3, 4, 5, 6, good. Everyone sees how I tested my code? This is really important. Part of your job is to always test code and make sure that everything works out fine. Okay? So that's perfectly fine. Now, I want to stop the infinite loop if ever I entered a 0. So I know this code is reached here. This is the next thing you're going to learn. Is you could actually cut the tree. You could branch out from the tree. So this while true, even though it's while true and it's always going to be true, so it's an infinite loop. If I put my mouse here, while statement cannot complete without throwing it, well, that you could ignore. This is never going to finish because it's an infinite loop, right? So if I run it, one more time, I could enter numbers here and it will never finish ever, right? So this is a problem. We can't make our application stuck either. So if the user enters a 0, I want to break out of this while loop. And that's where the word comes in. So if user value equals 0, we do a break. Now this is a reserved keyword for while loops, well, for any loop, which basically means I want you to stop the loop what do you call this? Predetermined? No, prematurely. So even though usually you have a loop that has like a range, or a for loop that has amount of sequence to do, and a while loop that's waiting for this to be false, we could break it at any moment with the keyword break. Right? This could be important because something happened, we want to break our thing. An error happened, we want to blah, blah, blah. So if I enter -1, it's no good. 1 is good, 2 is good, 3 is good, 4 is good, 5 is good. And if I enter 0, our application finished. See, process finished. Right? So that's what the that's what the break does. And you got to be careful. If the break was inside, let's say here, would my application finish or would it continue forever? Right? Again, let's test out our theories. Make sure that we know what we're what we think is what we know. So here, if I enter 0, I'm still inside of an infinite loop. If you guys look at the code, do you understand why it's not breaking out of my infinite loop? Just give you a second to look at it, think about it. Well, the break breaks out loops. But as we talked about the scope of things, this break is within the scope of a do while. Right? So because it's within the scope of a do while, this break only affects this do while. It affects the first loop that it's in, the first scope that encapsulates it. So even though this break is working correctly, it's actually, if we do it here, let's say cout reached. Okay. If I do this cout reach over here, you'll notice even though I'm doing 0, it's never gonna hit that reached. That's because before this do while finishes, we're breaking. Notice when I highlight the break, this while loop gets highlighted. It's breaking out of this while loop. So this while loop gets broken, then it goes inside this while loop and it says, well, the answer is true, do it again. Do it again, do it again, do it again. All right? Let's put out a cout here. Let's put outside scope. Zero, outside scope. 0, outside scope. Notice we're never touching the reached. Cool? Anyone has a question? So this break, we need to put it in the correct scope. And in this case, the correct scope is outside. Cool? And you'll notice now reach is going to be reached, but the outside scope is not. Cool? Any questions about break? I'm going to move on. Okay. This could be useful based on what you want to do. I don't know. I could show you other examples if you want to. You just got to ask me. Okay. So if no one says anything, I'll move on. So that's break. We also have another key term reserved for loops. Actually, before we move on from break, so this break, in this case, what it's doing, it's not only breaking our while loop, it's also breaking out of our application. Because the moment this while loop is finished, our application is finished, right? So, let me clean it up 1 second. So, if we look at this, what other word can I put at line 28 where the break is? What other term can I put there to end our application?
Return?
Yeah, a return. Why a return? Well, because public static void main is a function, and any function has the power to have this keyword return. Even though it's void, it's not returning anything. We're not returning anything. We're just ending that function. So writing return here is just as good because this while loop if it ends, well, there's nothing else in there. It's not like we put a code here saying outside infinite loop, let's say.
So we can also use system.exit.
Yeah, but the system.exit, you got to be a bit careful with that. It's based on the OS and whatnot, but that's fine too. So system.in.exit, you said? No,
System.exit.
there we go.
Yeah.
Okay. So that's fine too. Just be careful with when you use this, okay? Depending on the OS, it might function a bit differently, okay? But in this case, it's perfectly fine. But the return, you'll have it in every language and everything, and something to note. And you'll notice that my IntelliJ, my IDE, is giving me out an error. The error is, well, there's an infinite loop here, and the moment that we break out of this infinite loop, we're actually breaking out of the application. So this code is unreachable, never reaching. But if I put a break here, actually before we do that, let's see if I can run it. No, it's not gonna let me run this. Give it a second. Da, da, da. So I put 0. You see my application ended, and we moved on. Now if I put a break here, and I uncomment this, even though it's gonna end my application, it's gonna end it after writing this line 31. Right? Outside infinite loop reached. Cool? So if anyone has a question, this is the moment. Otherwise, I'm moving on. So the next keyword that's reserved, so actually let's write it here. Loops, keywords, I guess. We got break, which stops the current loop, so scope. Okay, and the next keyword we have is continue. And again, there's no capitalization. I'm used to doing capitalization. If you do a capitalization, it's something else completely, right? So it doesn't work. The next keyword is continue, and this is interesting. Continue, what it does, it's basically like a break, which it stops from reaching this part, but it makes the while loop ask the question again. So actually this one, I'm gonna leave it there. It's gonna stop our application if I leave it there. Here, I'll comment it out. Actually, you know what? Let's take this out, put it inside of a function. So what I'm gonna do is refactor, and we gonna functional parameter. Let's see what it does. No, that's definitely not what I want. 1 second. Move members. No, introduce. Extract method. This is what I want. So the name of the method would be breaking loops, I guess. Okay. Blah blah blah. You see it. It's giving the scanner. That's the only thing it needs. I'm fine with that. Go next. Okay, so this, what I did was refactor, which is just put that code inside of a function. So like this, we could ignore it without commenting it out, and it's useful for in our case. And for now, we could go ahead and comment it out because we're not going to use it. The next thing is let's use continue. So let's create a for loop, int I or x or whatever you want to put. X is less than 10, x plus x. And inside this, I want to do a bunch of things. I want to say let's say x plus, we're going to concatenate some strings, is Well, actually, let's do a couple things. We're going to say if x is an even number, so modulus, find the remainder of x when it's divided by, when it's modulus 2. If it equals to 0, there is no remainder left, then x is a even number. So in this case, we could write x is an even number, right? Then let's say root, and then let's say I don't know, let's say x is also divisible by 5. Okay, so the first one is to say it's an even number, the second one is to say, hey, it's divisible by 5. I really don't know where I'm going with this, but let's just do it. Divisible by 5. Alright, let's just run it to see what we get. So for x, that's going from 0 to 9, right? It says the first number is an even number, woot. 0 is divisible by 5, okay. Well, this is again because 0 modulus anything is always going to give 0. This is not the correct answer, but it's fine. 2 is an even number. It skips the divisible by 5, woot. 3 is nothing, woot. 4 is so for so on, right? If you have problems with modulus, I suggest you look into it because you could do really funky stuff with modulus and it's a bit powerful. It's something that's used in programming a lot if you understand it. If you don't, you're probably never going to use it, but that's a shame because it could make your code much smaller. Anyway, so in this case, you notice that we're printing woot at all times. And what I want is if x, actually, you know what? First of all, we're gonna do, we want to know which number we're at. So x, and that's it. And at the end of this, we're just gonna put a new line so it kind of cleans it up. Okay? So now let's just run it one more time. Let's take out this line. So now you see that we're going through every number. 0 is an even number, woot. 1 is not an even number, so you just see woot. 2 is an even number, woot. 3, just woot, etc. Okay? And at 5, you see 5 is divisible by 5. Okay? So now let's do something. We're gonna say this number over here. I know the code is a bit ugly, I'm sorry for that. If x is also, if x is divisible by 3, we're gonna continue. And what continue will do is it will skip the rest of the body and go on to the increment, then to the condition, then back to the body. So whenever the continue is going to be hit, either inside of a for loop or a while loop, it will skip the rest of the body. Right? So notice 9 doesn't have a woot, 3 doesn't have a woot, etc. So let's bring that up a bit. Let's say if we get to 15, right? So let's say to 20. At 15, if we reach x being 15, it will print 15. 15 is not divisible by 2, so this is not. 15 is divisible by 3, it's going to continue. And 15 is divisible by 5. So this, we shouldn't see it because of the continue. Right? So let's run this. So if we look over here, even though 15 should have been divisible by 5, we don't see anything. The only thing we see is everything before the continue. And in this case, everything before is just this. Right? Notice 6. Where is 6? 6, system.out.println, that's line 25. 6 is an even number, that's this line. Then 6 is also divisible by 3, so this is true. It's going to continue, so we don't have the root.
Hello?
Yes, hi.
Hi. Can you repeat what exactly continue does?
What continue does is it stops the loop's body, and that's it. So what happens is continue will not let these lines go. If it hits continue, look, this is inside of an if statement, so it only does it if this is true. If this is true and continue is hit, from line 30, it will not go to line 31. It will directly go to incrementation. So let me show you this visually a bit. This is going to be a bit more. Right? We're going to learn about debugging later, but this is going to give you a visual aspect of how this is going to happen. Notice this is the computer currently. I stopped the computer, and this is called debugging. I hope you've seen it. If not, I'll teach you later. What it's currently doing, the code, it's stopped at this line. And again, remember, the computer is really stupid. It can only do one line at a time, and it's asking me to go from one line to the next, okay? I'm not gonna decide which direction it's going, but I'm gonna see how it's going. So the first line, what it's doing, it's gonna initialize x. You're gonna see the variable created here. Then it's gonna check the condition, and then it's gonna go in the body. The increment is done after the body, right? So let's start this. So I press step over. Notice x got created, x was less than 20, so it comes in the body. Let me see if I could put the console layout settings. No. Can I put this here? Okay. This is gonna look a bit better for you guys. So I have the variable x. I have the variable x. We're at line 25. So as soon as I do line 25 on my console, it should show me 25. Sorry, 0 I meant. 24. Why was I saying 25? I have no clue. So 0 was our current x. 0 is being shown. Now, is 0 divided by, modulus 2, does it equal to 0? Yes, it does. So it's going to go inside line 27. And it's going to show me that number. 0 is an even number. Is 0 modulus 3 equal to 0? Well, yes. Any 0 modulus anything will always give you 0. So it's going to go to line 30. And now look at this point. This is the interesting part. Because we're at the continue, from here it would usually go to 31. But because of the continue, it will directly go to incrementing x from 0 to 1. Right? And now it's going to increment, check the condition. It incremented x to 1, check that 1 is less than 20, go to line 25. Line 25 says print out x, which is 1. What's the variable here? 8, f8. So it prints out, actually, there we go. Let's put it back. Put it back here. We don't need to see that other stuff. So we see the x's here. So now it says print line 25. I say okay. 1 is printed. Is 1 modulus 2 equal to 0? This is false, so it's going to skip line 27. Look what happens when I make it go. It skipped line 27 because this was false. Now is 1 modulus 3 equal to 0? Again, it's going to give you false, so it's going to skip line 30. And because we didn't hit continue, it's going to keep on going. Right? Wood gets printed. Is that no? Print ln. Okay, we're back to here. Increment x, then check. Is it less than 20? 2 is less than 20? Yes, go here, print 25. Is 2 modulus 2 equals 0? Yes, so go inside, print that. Look here again, 3 modulus 3 is going to give me 0. So this statement is true. Because this statement is true, it's going to go to continue. And because I hit continue, it's going to finish the body prematurely, earlier than it should. It's skipping everything after continue to increment x and to check the condition again. Does this make sense?
Yes.
If anyone has any other question, let me know. So this is how the computer goes. Remember, it's always top to bottom, one line of code at a time. Actually, I added something here. Right? So the computer is really stupid. It could only follow your instructions, and this is something you need to understand. The computer is a dumbass. Okay? Well, it's not really a dumbass. It's just it can't make any choices of its own. It always has to follow our instructions, and this is really adamant to understand because we feel that when you tell, so let's say when you tell your mom or dad to cook something for you, you kind of expect them to know what you hate or what you're allergic to for them to not cook those things, right? But in this case, the computer, even though it might know that for some odd reason, it will never do that choice for you unless it's been instructed, it's been given an if statement, a loop that decides which direction or what to do. And this is important to understand. Now, if I keep on holding my, actually, let's rerun it one more time. If I hold down F8 and let it go super quick, oops, that's the wrong button. No, actually, I just took this out. Let's do this one more time. So if I hold F8, notice this is how fast it's going. And this is actually slowed down because I have to hold down the key. If the computer is never held down by the user, the programmer, it actually goes in milliseconds. It goes so fast that, I don't know, it's super fast. Like, yeah. So, and again, this line of code, we only have, let's say, 10 lines of code. Eventually, you have millions and trillions of lines of code, and those are the times where we want to speed it up. From 1 minute, we want to make it 30 seconds, and etc. And you're going to see that's basically what Google and everyone else are doing. Let me see, developers, google.com. So let's say as an example, if I go to the web, you'll see they're going to talk about how to improve your time load at all times. And if you go further and look inside that, I think they have a talk about this, case studies. That's not what I want. They talk about these case studies where they retained users or that they lost users because the page needed to load more than 3 or 4 seconds. And this is important to remember because as the time passed and the current era of technology and whatnot is we become really impatient people. So a lot of times we have to wait a few seconds for our food or for this. We get pissed off and we quit. We go to somewhere else. And we need to kind of agree that that exists and be able to manage for it, solve it, not just be annoyed by it, right? You being annoyed is not going to bring you more money. It's just going to make you be the loser that doesn't get it, right? So anyway, any questions or otherwise I'm going to move on. So again, continue is for the current scope of the loop. It could be while loop, for loop, whatever the loop is. It's the same as break, except breaks finishes, stops or finishes the current loop, while continue will skip the rest of the body, the loop body, okay? And again, it's based on the current scope. This is important stuff to remember. So, anyone has any questions? Okay. Next thing I want to do before we go to, give me a second to think. Should we hit multi-dimensional arrays? Yeah, why not? Actually, multi-dimensional arrays, we're going to be using it inside either in your project or your final exam, so maybe we'll do a little parts of it. Okay. So again, let's go ahead and extract this thing and make it into, this was, what did I name the other one? Whatever. Loop, continue. Actually, a better word would be continue. loop, refactor. So breaking loops, continue loops, and again I'll do that there, and we'll break it. And maybe we'll copy the scanner. Yeah, we'll copy the scanner so we don't have to pass it. Okay. And again, I'm gonna give you all this code, so don't stress on this. So the next thing is we talked about it last time. Is we created some arrays, right? Which was, let's say, an integer arrays. That's the grades for all my students, and we could initialize this in two ways. One, we could have given values directly, or we could have given it a size. And if you initialize it this way, it's gonna use the default size of int, which you don't want. So you want to go through each one of them and set a value. Good. And we could have, so if we're gonna do that, might as well just initialize it directly by saying the first student got, let's say 78, the other student got 98, this student got 45, and another student got 32. And let's add one more, 50, well, let's be a bit more happy. This guy passed by margin. Now, if we look at this array that we have, the size or the length or whatever it is that they use is gonna be of, well, 1, 2, 3, 4, 5. The starting position, so the starting position, actually let's go with it. The starting position is gonna be 0 always. 1, 2, 3, and 4. So even though it has 5 elements, the starting position will always be 0. Cool? And that's perfectly fine. And if we want to change a value, we do grades, add position 0 equals, let's say, 34. And if we want to showcase if we want to print to the screen one of those grades, again, we do grades, add position 0. We're gonna get to multi-dimensional in a second. So notice that the value was changed, and if I print the value, it's 0. A lot of times I see a mistake, which is I want to print the array, so I'll just go ahead and I just put grades like this. You'll notice that when I do this, you'll get this weird value, right? And this weird value is actually not so weird. It's actually the address of where this array is being located. We're going to talk about addresses as soon as we get to objects. This is important. But this is the address inside the memory, right? And this is actually not the array, but the location inside the memory. And we're going to talk about that when we get to objects. Okay, so just remember to always give a position, right? I also cannot do this, because now we're saying 34 is an address inside the memory. This does not work, right? Any questions? I'm going to complicate this. If you don't understand, you need to tell me now. Okay, so
can you explain me once again, please?
which part? All of it?
No, the 34th one, grade 034.
So grades at position 0. So whenever we have these brackets, we're saying inside my array, go to position 0. So we're here. And again, this is a memory thing. So let me grab actually my pen. Let's say this is the memory, right? And inside there you have zoom that's working its ass off, right? It has a lot of space, etc., etc. And somewhere along the way we have this thing. I'm going to talk again about this. This is how the memory works. This is really important part. Actually, you should have heard about this. This is called the heap memory. That's an E, by the way. Heap memory. Sorry for my handwriting. It's the mouse. It's really painful. And what's going on with the heap memory is the moment you create, so let's say line 24, the moment we create an array with the size of 5, you don't actually have the array of size of 5. You have this thing which we call a pointer or reference, which is going and pointing to where that array exists inside the memory. This is why we get printed this memory. This is the location, right? The location inside the memory. So what I mean by location is, let's say I have never seen you guys, right? Most of you guys, we never had a class together. So I have a list that says who you guys are, where you live, and I could contact you directly and tell you what to do and whatnot, but I've never seen you. And this is the same thing with the grades. Even though I have a grade variable and I could tell one of the positions to change value, I don't actually have that integer. I don't have the student or whatever. So when I'm asking to go to position 0, it's going inside my array at position. So we have 1, 2, 3, 4, 5. It's going at position 0, this location, and setting it to 34. Right? I still don't have the array. I know where it lives inside the, let's say inside Montreal. You could say the heap is Montreal. I know where it lives inside Montreal, but I don't exactly have direct access to it. I have to call someone who goes and changes the value for me. I have to tell him where that guy lives in Montreal or inside the heap memory, and he will go and change that value for me. Does that kind of make sense? And this is how objects work, and this is really important. So you have the heap and the stack, and we'll talk about these as we go along.
Thank you.
No problem. So here, when I try to access grades directly, it will always only give me an access, a location, right? Otherwise, this would be like the location of where our school is. 60, I don't know where street stuff name is, but let's say 6080 Laurando, right? Let's say that's our address. So if I want to access that address, I need to use the word grades, and that gives me that address. From there, if I want to access a room, in this case, this is an array, and I want to access one of these positions, I have to mention the position inside these brackets. And what it's going to do, I'm going to go a bit further. You don't need to understand this completely. What it's going to do is, based off the position you give it, it's going to take the size of an integer, which is 4 bytes, right? It's going to multiply 0 times 4 bytes, and it's going to know which location inside this to take. Again, this is a big chunk inside the memory, and this could have been really long too. How does it know where the memory, where does the zeros and ones for this value starts at? Well, from the initial location, from, let's change color 1 second, from, where is my color palette? Give me 1 second. From the initial location, which is this, right? That's the initial location that's being seen here, right? This initial location, it's gonna figure out which one I'm at by doing the position, so 0, multiplied the type size. So in this case is integers and their size of 4. So each integer has a size of 4, right? 4. Do you see what I mean? So because I know the size and because I know the position, so 0 times 4 is going to equal to 0. So I'm not going to move anywhere from the address. So I'm starting at this location that's given, the initial location, and that's where my value is. So from here to 4 bytes of location, so 4 bytes being, again, just to make sure, 1 byte equals 8 bits, right? So 4 times 8 bits, so all of that, 4 times 8 is 1630, it's a lot of numbers, okay? 32 bits, right? Am I not mistaken? By 8 bits, we got 4 of 8, so 4 times 8 is 32. 32 bits here, 32 ones and zeros are reserved for this value. So from here, it reads forward 32 bits. Right? Does that make sense? And now if I say, hey, go get me grades at position 1, it will do 1 times 4, right? And again, this is bytes, right? So it becomes 32 further down. So it's gonna start at, let's change color, let's put pink. It's gonna start at this location. And now it's gonna be able to read the next one because it has of size 4. So all of this is for that. Does that make sense? It's pretty cool. For beginners, this is, you're probably gonna forget this, but what's so cool about this is, let's say in Java you can't because it's a really high level language. It won't let you access outside of your memory. But in C++, you could actually directly access any parts of this or go outside of it and do really funky stuff. So this is a really good knowledge to know. I hope it kind of makes sense. Over time, as you figure this out, you could optimize your code even further because this is a big limitation that we see here. Having to use someone else's way of accessing our variables is a pain in the butt, basically. Any questions, guys? And again, we'll come back to this heap again for objects, which is everything else. We have the primitive type and everything else, objects-wise. It's all gonna be this thing we call references, and they're all on this heap. And this heap, you could think of it as Montreal. It's basically a big city, or the memory, and we need to know where our value exists inside that memory. And this is a must know for if you ever want to go to, let's say, mid-level. This is a must. In junior, you're gonna be learning this and finalizing it and, you know, making that knowledge solid. But if you're going mid, you need to have this down. No more doubts and so on. Okay, so we're good. Clearing in 3, 2, 1. And again, by the way, even though I say mid, you need this, okay? You'll notice some of your friends are going to become mid or senior. The titles is based on the company. So sometimes there's this guy who's a senior, right? Senior developer or whatever, and the guy knows nothing. And this happens, but you gotta also understand that if a company makes everyone senior, it doesn't mean they're good, and it doesn't mean their salary is up either. So you gotta kind of be careful what these kind of represent based on the company. I know some companies, they like to make the titles super high, so you kind of get, kind of reels you in. But a lot of times they're a bunch of, they don't know enough. And if you become the high end of mid and senior, you'll notice you could apply anywhere, you could learn anything, you could do pretty much anything. And that's a really cool thing to be able to have. The power of not being controlled by others. And this is important. Why, again, I'm going off topic, is, well then, you know, then you're not, you're not controlled by others. You don't have to take shit from other people. You could just say, you know what, I don't need this job. I quit and I go somewhere else, and I'll get paid higher or the same amount or more benefits and so on. The better you get at these hard to grasp knowledge, the more power you will have to decide what you're going to be doing, to decide how much free time you will have. And this is really important. Anyway, but again, to gain this knowledge, you have to work your ass off. This is the part that everyone hates. Let's move on. Any other questions about why this printed out an address and this printed out a value? So this is something called dereferencing, and we'll come back to that. So 34. Actually, we don't need to see that. Okay, so the next part is, well, now this is a one-dimensional array. What it's doing is basically, it's a linear thing, you know? If I wanted to, by the way, if I wanted to, I could print all of the stuff in my array. Position is less than grades. Because this is an object, we're given a lot of functionalities with it. One thing is the length. And we do position. And we could do grades at position. So now if we print everything out, we get all the values, 34, 98, 45, 32, 60, right? Notice the 78 doesn't exist because we changed that value, right? Change the value at position 0. Now that's fine and dandy. Let's go a bit further. I'm gonna keep that there for you. I'm gonna extract it to a method later. Actually, let's go ahead and extract that. Yeah. Refactor, extract method, and let's say simple, or let's say, yeah, simple array, okay? Now, let's go a bit more funky. So in this case, we're gonna create, so to create an array, let's say of, I don't know, again, let's say your ages, okay? And again, one thing to note is when I create a variable, the name, because it's an array, I made it plural. And this is something to always do, okay? Because later on we use variables, we'll notice age and ages, you know, with the S, it tells you there's more than one. So you don't have to always check what the type is. And this is something to do over time. So anyway, if we do your ages, it becomes like 24, 43, whatever. Okay? Now, what if I wanted this to represent something more? I wanted this not to be just linear, one thing like this. Actually, let's make some a different variable. Let's say I wanted to create a maze, right? Let me grab one of this. If I wanted to create a maze, whichever one, who cares? Let's say this one. If I wanted to create a maze, let me mention a new tab. If I wanted to create a maze, I kind of need to define at each location what is there. Is it a wall or is it an empty space? Right? And we could do this. If we look at this maze, we see all the walls are black and all the empty spots are white. So what we could do, it's either use an integer or a string, whatever you want to do, or even a color, to mention that this location in the array is an empty spot where I could walk, or it's a wall. Actually, let me go ahead and do another annotation. So if we were to look at this inside programming terms and whatnot, we could make this into a two-dimensional array, and we could give positions to everything. So let's say this is position 0, this is 1, 2, 3. Okay, sorry for my handwriting. See, I'm not really going in a straight line. This is 5, 6, 7, right? And this, we could keep going, and each value will represent what's there. Is it a wall? Is it a empty space? Or is there an enemy or a treasure? And what's interesting is this is one straight line, but we need to have this in two-dimensional, right? One dimensional is the X, right? We're going either this way or this way. Well, now we need to make it two-dimensional. Again, the computer doesn't know about dimensions, but for us, visually, two-dimensional will make it much easier. Going up and down. Does this make sense? So in this case, even though this is going one direction, we need to have another one over here that's going that's going in different locations. Does this make sense to everyone? So we want to create an array that's kind of like a square shape, an array that has an X and a Y, an array that has a positions, the what would this be called? The width and the height. No, that's not the correct. 1 second, I'm gonna ask. Babe, what was that thing we could say for the row and? There we go. I remember the row and the columns. So what we want to do is something that says not X, but the row, which location it is. Actually, this would be the columns, my bad, because we're seeing it like this. So this would be the columns, and this would be the rows. Which row are we talking about? Are we talking about this row, this row, etc.? So this is important to note for ourselves. Don't use X and Y because we don't know exactly what X represents or whatnot. But row and column, that's a beautiful wording. So let's go back. Let's close this stuff. So over here, let's say it's going to be our map to our game. And right now, what we have is basically columns, right? Well, actually, we only have one row with 4 values. What we want to create is not a one-dimensional array. We want to create a two-dimensional array. So we're going to add those 2 brackets, which would represents one the row and the other one the column. And again, you could have named whichever one you want to rows and columns. You'll notice that it makes an error here. And if we put our mouse over it, it says, well, I require an integer array, but you gave me an int, right? When we only had one array, this was an array of integers. When we have 2-dimensional array, we have an array of integer array of int, right? So it's a bit weird, but basically. So what we could do in this case is each one of these values will represent another array. Right? So look here, we said we have an array of integer arrays, and currently it has nothing in there, but it's an array of integers. This is how you should actually read it. It makes more sense. An array of integers. Everyone with me? This might be a bit confusing, but this is one of the harder parts. At the beginning, makes it a bit hard to read. So what we're gonna do is actually put these in different lines, and it's gonna make more sense. So I decided, you could have decided whatever you want, that the first array is gonna represent my rows. Okay? The decision is up to you how you would deal with this. It doesn't really matter. So the first locations is gonna be my rows. The second location is gonna be my columns. Okay? So I'm gonna put it as a comment. First is rows, then it is columns. And this is gonna be a bit more sense. So let's put some values in here. I'm gonna make it easy so we can see the values. 0, 1, 2, and let's say 2. So just 4. And over here we're gonna do 4, 5, 6, and 7. And over here we're gonna do 8, 9, 10, and 11. And again, I put different numbers so you don't get confused, but you could have had the same numbers everywhere, right? 12, 13, 14, 15. And I'm just gonna clean it up a bit because, you know, easier it is for our eyes, the better we're gonna understand things. Oops, actually. Cool. The spacing doesn't matter for the computer. The computer doesn't care about anything. When it builds everything into code, it's gonna make into zeros and ones, and all these spacings is gonna be erased. The spacing is again visually, because clean code, readable code is our main goal. So far, we created an integer 2-dimensional array. So basically it has rows and columns. And this is what it looks like because we initialized it. Now, let's see if you guys understood. So if I go ahead and print my map and I give it a value in here, I'm not going to say what that value represents, but let's say it's a position, but which one, I won't say. Let's say 2. And then, again, this is not going to be good. If you think about it, actually, I'll leave it here for a second. I'll actually give you a hint. What happens if I do this? what happens if I do this? And what happens if I do, let's say, this? So you guys look at it for a second. Try to determine what the value is going to be on my console. And I'll give you a minute. When it hits 230, I'm going to run it. And this is interesting. To understand is much better than to just watch. Sorry? Now actually, you know what I'm going to do? I'm going to bring back our big memory thing in here for a second. So let's go back to our heap memory. I don't know if any of you guys figured out what's going to be printed.
11, sir, 11.
So the first one, the map gives you the address of the map, and the second one, map 2 gives you the address of the location of the 2, and the third one, map 23 gives the number 11.
Okay, very well done. So the first one, again, remember that all of this, we don't actually have them. It's addresses of where they are inside the memory. So the first one that we do here is going to give you the address of where the array of arrays is inside the memory, right? Remember, this is an array of integers, right? There is no such thing as two-dimensional. It's just a visual thing for us. So an array of arrays. So here, this is going to point out to somewhere in there. And inside that, we notice that we have 4 rows. So this array over here has 1, 2, 3, and 4. Okay? So this first one is going to give the address of where this array of arrays is. And what I mean by array of arrays, let me change color here. Let's go to white. This this array of arrays is actually pointing to other arrays. And if we notice, we have 4 integers in there. So this one is pointing somewhere here where it has 4 values. And inside those values, we actually have values. I'm going to show you that in a second. This one is pointing to, let's say, over here. Again, it's random locations because this heap memory is shared with a lot of other stuff, right? So, again, 4 stuff here. This one is pointing to, let's say, over here. And this one is pointing to, let's say, over here. And it could have been right beside each other too. You don't know that. We're just randomly giving it spots. And inside those values, well, it's an array of integers. So the last part is, well, these are values. So this is 5. This is an address, right? This is an address. This is an address, a different address. This is a different address. So AD for address, right? It's the same thing as this, but these, the final ones, are different values. So this was 0, sorry for that. This was 1, 2, 3. Sorry for my handwriting. 4, 5, 6, and 7. And it keeps on going. This is 8, 9, 10, 11, and 12, 13, 14, 15. Right? Do you guys see this? Does this make sense? And what's so interesting, understand that this part, this first array, is an array of arrays. There was no reason that our arrays all needed to be size 4. We could have made those arrays of different size because, again, they get allocated somewhere inside the memory. They get some space reserved for them in the memory. So this part, let me see if I could, oh, well, I'm going to press saved, but how do I, mouse, okay. So if I wanted to, I could have made this one into a bigger size. and it would have been fine. The only thing that would have happened is here, let's go back to our color. Here, well, let me do a different color. Here, this one, when it gets, draw, there we go. It's not letting me draw anymore. Draw. Okay, there we go. So this one, rather than finishing at 7, it would have actually finished at 8. Do you guys see that? Do you understand that? These are addresses. There's no rules that says this should be at that size or that size. There's nothing that says these are all the same size. Cool? So if I run this, let's go back to my mouse. If I run this, like he said, the first one is going to be an address. The second one is going to be, again, an address because it's the address of position 2. So 0, 1, 2. So this location is going to be given to us. And the last one is saying, in the second array, so the second row, go to position 3. So 0, 1, actually this is not the second row. This is 0, row 0, row 1, row 2. So that's the row 2 at position 3. So position 0, 1, 2, 3. Give us the value that's here, and that's 11. Cool? Any questions? I'll let you look at this for a second. I'm just going to grab some water. This is important because OOP, everything is a reference, a pointer, a location in the memory. There is no such thing as having the value directly to us. And this is a problem that junior developers have, is they don't understand this heap thing. They don't understand that this is not something we have directly on, but it's a location that thing is stored. It's the same as when I have your files. I don't know you directly. I've never seen you. But on my file, it says who you are, where you live, and etc. And if I need to give you instructions, well, I go to your address and talk to you, or I give you a phone call, or I give you an email, right? It's the same kind of thing. It's like this is a file, and the actual person is somewhere else. And that location is in the heap. And this is something that junior developers will have a lot of hard time, the entry-level beginners, basically. Okay? I'll take a screenshot and I'll send you guys a screenshot. I think it was pretty good. Well done screenshot. Save. We save that in this folder. Show in folder. Okay. Cool. So, having that set, I'm going to clear that. Okay. Now there's another way we could have created, well, again, this is that. We could have also changed values, but we also need to give, we could change a lot of values. So again, we could change a specific position. We need to give it the row and the location. So 3, so this is row 0, row 1, row 2, row 3. I'll even put a row 0. Second, let me actually put that after. Row 1, row 2, row 3. And the columns, so this would be columns. Let me see if I could do that. Come on. There we go. Columns, this would be column 0, 1, 2, 3. Cool. I hope this visual thing is going to help you out. So here, me saying row 3, again, I assume that rows represents this. I find it easier, but you could have mentioned whatever you want. So row 3 would be this one, right? So this whole thing. And at column 0 would be 12. So change that value to, let's say, 45. what's going on? Oh, I put int. So here, map is the variable name. Cool. So we could change the value at a location. Now, if I were to say map at location 2 equals 34, you'll notice I get an error because that's, again, not a value of a position, that's a integer value. So it's not a reference, it's not a location we're looking at. Cool? So here, however, I could have done something like this. Well, in this case I can't, because it's not being initialized. I have to say new int, and it has of size 3. And then I could give values and so forth, so on. And there's a couple other ways I could have created this, but this is fine. Right? And if I wanted to print all of this out, well, I need int row, which starts at 0, and then I ask for the map, give me the length. Notice I'm asking the map, so this is the first array, not the second one. And I'm gonna say, oops, actually I'm gonna say row less than that. And over here I'm gonna say row. So now I'm going through each row, but that's not enough. Going through each row is not enough. I also need to go through each column, right? So in this case, I'm gonna say another for loop. And column, I'm gonna say less than. What am I gonna say less than of? I'm gonna let you guys answer that.
Map 2, sir.
Map
2.
2
0 or 1.
at position, you're
One
saying?
sec. Yeah.
Okay.
Like the upper one, print and map dash 2.
One more time, I couldn't hear you well. Sorry.
Yeah, sir, like above, like map at index 2, like that.
Yeah. Okay. Map at index 2. Then what?
So not 2. It will be 0 or 1. It will be 1.
Well, I have an error here. Map 2 gives me an array.
Dot length.
Aha. So that's good. Dot length. Okay, we'll try this out.
Sir, it will be 0 or 1.
What would
Not
be
2,
0 or
sir.
1? Sorry, what would be 0 or 1?
Sir, 2.
This
Yeah.
2?
Yeah.
Okay, let's see. Okay, so I want to reproduce this inside my console. Okay? So what I'm going to do, remember that this is going through each column. This is going through each row. For each row, I want to go through each column. And at the end of that, I want to go to the next line. So I'm going to just put this println after. But inside each column, I want to print that value. So we're going to say map at the row, at the column, and I'm going to add an extra space so it spaces out the values. Is this clear? So for each row, go through each value, print it out, add a space. After you're done with the whole values, make a new, go to the next line, and repeat. So if we,
Hello?
yes, hi.
So there's a change. I think some here map 2, it will be a changing value.
Yeah,
Should be a changing value. It
exactly.
should not be static.
So notice that we got an exception error. We'll talk about exceptions in a bit. We got a array indexed out of bounds.
Yeah.
So map 2 is specific to row 2 here.
Yeah.
And inside row 2, the length is always going to give me the same value. But
Yep.
remember, we're going through each row, so we
Row,
shouldn't
yeah.
rely in a
A row.
magical number.
Yep.
So what should I be putting here?
So row.
Yeah, exactly.
It should be a row length.
Exactly. So because we're going through each row, we want to determine that row, what's the amount of columns it has. Notice that some columns have more, some has less, right? So now if we run it, we still got that, line 39. Oh, this part, it doesn't exist anymore. So row 2, column 3. Because we recreated this. This part is giving us an error. Let's just change the location to row 3. Okay, because we created a new int. This integer is smaller. It only has 3 spots. So let's do this again. So notice now we have our table. Let me actually put one last thing here so it kind of cleans out. Let's run it again. So notice our table, this is the value it looks. So if we look over here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 8, 8, 8, 9, no, now I got 0, 0, 0. What happened here? Why do I have 0, 0, 0?
So because map to new int.
Yes. So line 34, we said this row created into a new integer that has 3 positions,
Yeah.
and the default value for
But-
integer is 0.
Yeah, but values are not initialized.
Exactly. I can't remember in Java, but I believe you could also initialize the values. No, you can't do this. Anyway, based on the language, you could do some funky stuff. I don't really want to give values again, so I'm going to keep that like that. And this, again, if we remember the maze, each of these numbers, we could have represented it as something there. And again, this shouldn't be taken because they're all integers. How do I make this into a map? Well, we could have said, as an example, actually this, well, let's say, because I don't want to go change numbers, I'm a bit lazy. Let's say if I was to print stuff, actually, let's say if the thing is a 0, so if map at row at column equals 0, well then I would print out a space. Else, let's say it's a wall. So a wall, it would be something that's blacked out. What character code was that? I can't remember. But let's say O is the walls, right? So now when I'm printing my map, I'll get something like this. All the zeros are empty space, and all the O's are walls. And if I wanted to, I could have said at the beginning of my thing, I'm gonna have a little wall like this, and at the end of my thing, I'm also gonna have a wall like this. And now we're cleaning it up, and if you look, our thing is now starting to look like a maze-ish, where here we have a lot of space, here we have a bit of space, etc. Notice that the O's take a bit more space than spaces. Actually, no, this is because it's just longer walls. Yeah. But yeah, and if they were all the same size, so let's say if I move this just to show, it will look like something more straight. Except for this one that has a size of, one more time. Right? We get something like this. And now we kind of have a map created where the O's are the walls, and this is our outer edge walls, and we have our top walls, and etc. etc. Let's put those things back. Any questions? No? So I hope this kind of makes sense, and this is the start of getting into objects, which basically everything, this is a question that comes in interviews a lot, is everything an object, yes or no? And to be honest, yes, everything is an object. Everything is a reference, so an array is actually an object. It's a reference to somewhere inside the memory. The only stuff that's not a reference to things inside the heap memory is going to be the primitive types. So the primitive types is going to be in the stack memory, and we'll talk about that in a second. So that's that for two-dimensional arrays. And if you wanted to go three-dimensional arrays, well, again, you'll do the same thing. Let's actually go ahead and grab this. I'm going to extract it. Oops, I missed a bit. Okay. So refactor, extract method. Two-dimensional array. Let's just put array 2D. Okay. don't think you're allowed to start with numbers in Java. I can't remember. Anyway. Now, knowing about two-dimensional arrays, if I would have told you, create me a three-dimensional array, so now what we're doing is we're seeing, now we had the rows, right? That was the rows. And we had the columns. And now if we go three-dimensional, we kind of, if we take it into like real world space, we have the depth, right? So now we're going this way. So this is the depth. And that's the world we're currently living in. And usually these, if you go into gaming and whatever, these would be represented by X, Y, and this is Z. And this is three-dimensional world where we currently are inside. We're actually in the 4 dimensions, but we could only understand 3 dimensions. If you want that, we could talk about that. It's a fun topic. And this is how a 3-dimension would look like, right? Actually, let me make it a bit cleaner. So a square becomes a cube. So now you have access to whatever's in front, but there's also things in the back. Right? So your cube has a lot of stuff. Sorry for my drawing, it's hard to do it with a mouse. Cool? And again, this goes here and then goes here. And this. So now if we look at this, we have 4 rows, we have 3 columns, and we have a depth of 4. So to create this inside, whoops, this is the wrong button, mouse. So to create this inside our Java, let's say again, we're gonna stick to integers. It could have been any type. We would add 1 dimension, 2 dimension, 3 dimension, right? And again, this is infinite. We could have gone and made this into as big as we wanted. So let's call this our cube. And new. And now this time, I'm going to create it by giving all the positions. So we said the rows is 4, the columns is 3, and the depth, the Z, is also 4. Right? Do you guys see it? So it becomes more complicated. To be honest, you probably will never use 3 dimensions. And if we wanted to, we could have gone into the 4th dimension, which is kind of stupid because there's no way of showing that inside programming. Because I don't know if you guys know, but the 4th dimension is time. Which is, again, I'm doing this for fun. My girlfriend's laughing at me. And over here would be time. We're gonna make it into a constant one. And now we have 4 dimensions. And again, if we wanted to, again, this is very stupid because you're probably never gonna do this in your life, but we could go as many dimensions as you want because the computer does not care. And these dimensions actually do not really exist. The only thing is it's an array of 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 integers, right? The way they're positioned inside the memory, this is an array of an array of an array of integers. So if we go by that basis, this is an array of 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 an blah 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 until we get to the last one, which is integers. Would you want to do that? I don't know. You do however you think it's readable. Remember, the main goal is readability, right? So again, if I do new int, it's being a dick with me. Now I have to, oh, I forgot to put the name for this. Too much is the word for this. And new int, and then I need to go give this values. Oops. 2, 4. Right? You have no limitation. Usually the limitations I see from other programmers is the limitations they give themselves. They think, oh, I have to do this because I learned it that way. There is no such thing. Right? So maybe I'll do another picture of this and then we'll clear all the tracks. So you will never reach there. To be honest, you'll probably never even do a three-dimensional array, because the more mentions you go, the weirder it gets, and the more weird it gets, the worse it could turn out for you. Right? So this is an abuse, basically. But if you ever get the chance to use it, hey, congrats. This is fun. If you go into gaming, you'll use a lot of these things. Maybe this too. And you might actually do this without even knowing, because this is, again, a memory pointing to another memory. And this is what objects are. So you might do this infinite array without even realizing it. And that's something to note. Cool. Any questions? So, well, I kind of want to start the next part, which is objects, but I want to give you a break. Well, I want to give myself a break, to be honest. I'm talking, you guys are just listening. Kind of tired. So, unless you have a question, we're going to take a break. And we're going to continue back from 3:30.
All right.
Cool. So no questions? All right, guys. I'll see you guys at 3:30, and from there we'll go to the next topic. Cheers.
Okay, sir.